All right, let's look at a couple more power rule practice problems. So for this one, nasty, right? Rewrite it so that you don't have any square root, cube root, or any x's in the bottom of the fraction. So let me rewrite this first before I do any calculus with it. The first one's looking fine. It says 3x to the 5th power. Leave it alone for a second. But look at the second term. It says 2 times cube root of x. There's got to be a way to rewrite this cube root of x. Okay? All right, so leave that 2 alone. Okay? But you can write cube root of x as x to the 1/3 power. Okay? Next, I'm now focusing on this x squared in the bottom of the fraction. I'm fine with this 1/3. Like, leave that 1/3 alone, okay? Write down plus 1/3. But rescue that x squared in the bottom as x to the -2nd power. And I almost rewrote that square root of 5, but there's no x here anywhere, right? So this is just a number. That's a constant. So guess what will happen when you take the derivative of a number? That will just go to 0, so we don't have to rewrite it. You rewrite only if x is in an awkward position, like in a square root, cube root, or in the bottom of the fraction, because we really want to use the power rule, okay? All right, let's get to power rule now. For the first term, what comes down? This 5 will come down to the front, and we have to multiply 3 times 5. So the derivative is 15x to the 4th power. Let's move on to that red term. This 1/3 fraction will come to the front, and I need to multiply this by 2. So you will have 2 times 1/3, which is 2/3. All right, exponent, we have to do subtraction. So you have to subtract 1/3 minus 1 for the new exponent, right? So 1/3 minus 1 is 1/3 minus 3/3. And if I subtract, I will get -2/3. Okay, so that's gotta be the new exponent for this red term. Oh, alrighty. Let's do the third term that I wrote down in green. This -2 will come down to the front, right? And it's gonna multiply with this 1/3. So what is 1/3 times -2? -2/3. And go down 1 from -2. That will be -3. Now, you can find the derivative of square root of 5, but that's just 0. So you can do plus 0, or you don't have to write it, okay? And I would just stop there. I mean, of course, you can rewrite this in like root form, or send the exponent that has negative to the bottom and all, but this is a fine answer, so I will stop there, okay? All right, let me do one more application problem on this bottom, about an equation of tangent line. A bicyclist, okay, it was a bicycle rider, okay, distance traveled in miles, t hours after starting a ride is given by this function. They want you to find the distance traveled. Now, for this part is easy. If they want you to find the distance traveled and they gave you a distance function, all you got to do is plug in the number they gave you, t equals 2. So let me find the distance traveled first, okay? That will be g of 2. If I plug in 2 inside, I'll get 14 times square root of 2 plus 2 divided by 3. All right, let's get a calculator and type that in. All right, that comes out to be 20.47 miles. So if you want to find the distance, that's all you do. You plug it into the distance function. But if they want you to find the velocity, we now need to do the calculus. So let's rewrite this g so that we don't have any square root or t in the bottom of the fraction. I'm rewriting this, okay? So rewrite the 14 square root of t as 14 times x to the 1/2 power plus, now this looks awkward, but that's simply 1 over 3t, right? So I'll write it that way too. I'll write the second term as 1/3 so that I can see the coefficient clearly. T. I just brought the t down next to it. Now I am about to take the derivative of this. G prime of t is equal to, you bring down that old exponent of half to the front. If you do that, let's see, I have to do 14 times half. Well, half of 14 is 7, so I'll get 7x to the -1/2 power, because half minus 1 is -1/2. All right, take the derivative of 1/3 t. What's that going to be? That's just going to be plus 1/3. Okay, now we're going to find the velocity at t equals 2. So only thing that you have to do is plug in this 2 into the derivative function. So do 7 times 2 to the -1/2 power plus 1/3. Let me type this into my calculator and see what we get. All right. If you type that in, you should get 5.28. And let's see what the unit for this velocity or speed is. I'll say miles per hour. Okay, so if they want velocity, find the derivative first and plug in the number into the derivative function. If they just want distance traveled, just plug in the number into the original function. Now, last one over here is asking for us to find an equation of a line that is tangent to this curve. So not related to the previous one that we just did, but you know what ingredients we need for equation of a line, right? We need x, we need y, we need m. Well, this one, they only gave us an x of -2. So sorry, they never give you what the y value is. So we'll have to find what y is by plugging in the x into the function. So y is equal to f of -2. What happens if you plug in -2 into the function? You'll get 1 over -2 to the 5th power. That's going to be a one ugly fraction. So what's that going to be? -2 to the 5th power. That is -32. So y value is 1 over 32, but it should be negative. So write down -1 over 32 as your y value. But let's go and find the slope. To find the slope, you don't plug it into the original function, but you have to plug it into the derivative function. The original function kind of is in awkward state, right? It's 1 over x to the 5th power. So I will rewrite this as x raised to the -5th power. So we rewrote it because x is in the bottom. Now take the derivative of this using power rule. Bring down that exponent of -5 to the front. If you do that, you're going to get -5x to the, go down 1 from the original exponent. So you're down at -6. So the derivative is -5 over x to the 6th. I know I rewrote it back in this fraction format. Let's find the slope. Slope is what you will get when you plug in that x value they gave us into the derivative function. So plug in -2 right there, you get -5 over -2 to the 6th power. And that is -5 over 64. I think it's 64, isn't it? Yep, it is 64. So slope is -5 over 64. Look at what I have. I have all 3 numbers I need to write the slope of a tangent line. Okay, I'm sorry, equation of a tangent line. So let's do point slope together. Y minus y1 equals m times x minus x1. Plug in everything we have. Y plus, because you see the y value is negative, 1 over 32 equals slope of negative 5 over 64, parenthesis, x minus x1. Oh, x1 is negative 2, so I will have to do x plus 2 inside. Well, notice both x and y values are negative. That's why we see a positive, a plus, and plus for the y and the x on that side, okay? So that's it for some application problems on power rule.